An electric car is a vehicle that is propelled by one or more electric motors using energy stored in rechargeable batteries. The first electric car prototypes were built and introduced already 200 years ago during the first half of the 19th century, thanks to the industrial revolutions. During those years, many scientific discoveries and inventions were made, so much that many people's lives in the most industrial countries completely changed. It was in the late 19th and early 20th centuries that the first electric cars, which at the time were called crude electric carriages, became very popular, and at one point they even outsold gasoline-powered vehicles. Unfortunately, due to technological limitations and high cost of batteries, the latter took over. Cheap, abundant gasoline and the lower price of vehicles helped the internal combustion engine cars to come out on top, becoming the reference technology for many years to come. During the 21st century, great technological progress, such as the invention of smartphones and computers, made it possible to develop and improve rechargeable batteries, especially lithium-ion batteries. Unlike normal batteries, lithium-ion batteries can accumulate more charge in a shorter time. These advantages have led to overcome all those issues that the electric cars had in the past, allowing the spread of electromobility. More than 10 years in industrial supplies have led JAES to become a qualified partner for some of the most important companies operating in the electric mobility sector. Today, electric vehicles are more efficient than gasoline-powered vehicles. Unfortunately, they still have some issues such as limited charge autonomy, long battery charging time, and progressive batteries degradation over time. But let's see how an electric car battery is made. This battery could be compared to the heart of the car and is also called accumulator. As we've already said, electric cars are equipped with lithium-ion accumulators, which are able to generate a large amount of energy. The lithium-ion accumulator is a type of rechargeable battery made up of cells. These cells are like many small batteries, which are similar to those we use in everyday life. The cells are installed in forms of modules and packs in order to produce the right voltage and amperage. A series of chemical reactions produce large amounts of heat that rapidly increases the temperature of the battery. Too high exposures can damage lithium batteries, which could even explode. For this reason, a refrigeration circuit connected to a radiator is passed through the cells in order to make the battery work at an optimal temperature and thus increase its duration and the operating performance. In addition, the battery is usually positioned on the floor of the car, which results in a significant lowering of the center of gravity, improving the vehicle's stability. Let's move on to the electrics of the car. Batteries provide DC current, but most electric cars convert it to AC thanks to an inverter. This transformation is fundamental, since AC power systems are more efficient than DC electric power systems. The inverter can modify the frequency of the AC current, which is sent to the motor. The motor can be synchronous or asynchronous, and it is able to vary its speed based on the frequency of the current. Thanks to this principle, it is possible to adjust the speed of the electric motor. If you want to find out how inverter and AC motors work, take a look at our previous videos. The main advantages of electric motor over classic internal combustion engine are different torque and high RPM. In fact, an internal combustion engine produces torque and power only with a limited speed range. For this reason, the transmission, which converts the engine power to momentum, which drives the wheels, must be equipped with several gear ratios that must be engaged one after the other as the speed of the car increases. An electric motor, on the other hand, produces instant torque, which remains constant over time, from zero speed up to its maximum number of revolutions, which is usually very high. This is why electric vehicles have peak torque available from 0 RPM. Plus, they don't need a multi-speed gearbox with numerous ratios, since they can use a simple single-speed transmission that produces high engine revolution and increases torque. Some models are equipped with a 2-speed transmission in order to increase efficiency at high velocity by lowering the rotating speed of the power source. When we want to insert the reverse gear instead, the inverter simply switches polarities of the motor, which will spin backwards, causing the car to move in reverse. At this point, the rotational speed is transmitted to the wheels via differential and drive shafts. Another interesting feature of electronic vehicles is their ability to convert kinetic energy back to electrical energy during braking. This is called regenerative braking, and it's a very clever system that uses the electric vehicle's motor as a generator to convert much of the kinetic energy lost when decelerating back into energy that will be stored by the inverter in the vehicle's battery. Today, we are experiencing a global transition to electric vehicles in order to reduce pollution and making greater use of renewable energy. But will our society be ready to stop using fossil fuels so soon? Are hybrid cars the best solution? Let us know in the comments below. If you found this video useful, please let us know by leaving a like and a comment. You can share it, and don't forget to subscribe to our YouTube channel. Visit JAEScompany.com to find out our next projects.